This is section 1.8, number 21, part 2. In part 1, I described the approach that we're going to use to the problem. So let me write it out again. dy dt plus 2y is equal to t squared plus 2t plus 1 plus e to the 4t. In the previous slide, I talked about how I can break this up into two problems. I'm going to find a particular solution that will work with this first term. I'll find a particular solution that will work for the t squared plus 2t plus 1, and a different particular solution that will work with the e to the 4t term, and then my ultimate particular solution will be a sum of the two. So here we go. The first problem we solve is find a particular function that can solve this problem, this non-homogeneous problem, where the right-hand side is a polynomial. So, as we look at it, we see, well, I'm looking for a function y whose derivative plus 2 times itself is a polynomial. The thinking is that y sub p1, the function we're after, must itself be a polynomial whose highest power would be 2, so I'm going to call it a t squared plus b t plus c. And I argue that whatever the function that solves this differential equation must be of this form. This falls under the heading of method of undetermined coefficients. We're going to plug in and determine what the coefficients must be. When we plug in and we take the derivative of y sub p1 dt and add that to twice y sub p1, we get 2a t plus b plus 2 times at squared plus bt plus c. And that's supposed to equal t squared plus 2t plus 1. We group like terms. There's only one t squared term. There are two t terms. There's a t term with a 2a coefficient and a t term with a 2b coefficient. And there are two constant terms. There's the constant term b and the constant term 2c. And again, that's supposed to equal t squared plus 2t plus 1. Well, this sets up three equations. The coefficient of t squared on the right is a 1. The coefficient of t squared on the left is 2a. A is going to have to be a half. The coefficient of the t term on the left is 2a plus 2b. The coefficient here is a 2. They're going to have to be the same. And this constant term, b plus 2c, is going to have to be the same as 1. So we write these three equations. The first one says that 2a has to be a 1, which says that a must be a half. The second equation says that the coefficient of the t term, 2a plus 2b, has to be a 2. Again, 2a plus 2b. Oh, just realized that I left out the t here. The 2a plus 2b has to be the same as the coefficient of this t term, 2. And finally, well, actually, let's go ahead and solve that. If a is a half, then 2a is 1. 1 plus 2b has to be a 2. And that says that b must also be a half. And finally, the constant term has to be a 1. And we write b plus 2c has to be a 1, but since we now know that b is a half, we know that a half plus 2c has to be a 1. And solving for c, that says that c has to be a quarter. And so we leave this slide with our understanding that our particular solution, so I'm going to just put in a box here, that what we found here is that the particular solution that solves this differential equation with right-hand side t squared plus 2t plus 1 is none other than 1/2 t squared plus 1/2 t plus a quarter. Okay. On the next slide, I'm going to check that that is in fact correct. Okay. So let's go to the next slide. On the next slide, we're just going to do a quick check. We're going to take the particular solution y sub p1 of t as 1/2 t squared plus 1/2 t plus a quarter, and ask if I differentiate it, y sub p1, and add 2 times itself, do I in fact get t squared plus 2t plus a 1? Well, its derivative is a 2 plus 1/2. 2 times it, I'll write it out, 1/2 t squared plus 1/2 t plus a quarter. I apologize, this is a 2t plus 1/2. So I have 2t plus 1/2 plus oh boy, mistakes. I apologize. The derivative of 1/2 t squared is not 2t. The derivative of a half t squared is just a t. I'm looking at this and saying something's wrong. Okay, so t plus 1/2 is correct. So let's get rid of this 2. One second, let me get rid of this 2. It's not erasing for some reason. I'm not sure why. So maybe I'm just going to cross it all out. Can I erase it now? No, I can't erase it. Not sure why I can't, so I'm going to have to cross it out. Okay. I now have t plus 1/2 is equal to plus t squared plus t plus 1/2. And sure enough, when I combine terms, I have a t squared term, I have 2 t terms, and I have a 1. And that is equal to the right-hand side, t squared plus 2t plus 1. So we did find a particular solution of that problem. Next slide. Now we're going to solve the differential equation dy dt to y is equal to e to the 4t. Well, this is more straightforward. The particular solution I try here is none other than a e to the 4t. And when I plug that in, I get a 4a e to the 4t, a 2a e to the 4t, and that's supposed to equal the right-hand side of just e to the 4t. Well, I realize that I have 6 a e to the 4t's here, and just a 1 e to the 4t here, so 6a must be a 1, A is a 6th. Erase that. A is 1/6, and my particular solution P sub 2 of t, P particular sub 2 of t, is just 1/6 e to the 4t. Putting this all together, I'll go to one more slide. Our original problem now, dy dt plus 2y equal to t squared plus 2t plus 1 plus e to the 4t. This solution will be made up of, a homogeneous solution of the corresponding homogeneous problem, plus the first particular solution, plus the second particular solution. The homogeneous problem I'm not going to derive. Be careful, but it is an e to the minus 2t, and so in the end, our general solution is k e to the minus 2t plus 1/2 t squared plus 1/2 t plus 1/4 plus 1/6 e to the 4t. That's it. I hope that helps. Good luck. Thank you.